To the few of you who decided to wait until the end of the day. I've been the last speaker before, so that doesn't worry me. And I often think that if no one's here, I'll enjoy looking at my own slides. The nature of the topic and the timing of the topic are such that this is a short talk with about 20 images, one tiny graph and no notes to read. I'm interested that you gave your talk about esperance. I'll refer a bit to the Nullarbor plain on our end of it. We should have a long conversation later. My talk is less detailed science, although we have a 3-day science convention that we're doing. But the messages that come at the end of this short talk are intended not just for SMK, for the science, but a broader audience in DEWNR, although this is the first time I've assembled this information for the talk. You'll see as I go through the talk why that's the case. There's a couple of take-home messages at the end and a little bit of geology at the beginning. Nullarbor to Naracoorte, DEWNR's extensive limestone and coastal karst assets. There we go. Quick bit of geology for you. This is all the continental assembly before separation. Here's Australia. Here's Antarctica, here's South Australia, and this area here and this gap here is what I'm going to concentrate on in this talk today. It has some special assets which I think aren't really fully understood or realised by South Australians in general. Here's a diagram of the continental separation, the separation of the plates. The important things about this are that here's Antarctica now, South Australia's here. This is all the splitting of the sea floor that occurred over that time. You can see there's a ghosted image of where Antarctica was at one stage and our coastline. The diagram doesn't show that the two continents did not break apart like this. They unzipped, starting from Western Australia, and the last bit that broke away was over near Gippsland in Tasmania. So they opened up like this, and the significance of that is that as they opened up, the ocean started to come in this gap, but it wasn't until the final break occurred that we had what we call a circumpolar ocean or a circumpolar current. Once we had that, we had the establishment of the Southern Ocean going right around the bottom end of the planet, and that generated a great deal of cooling conditions as an open ocean network. And although there's a lot to be said about that, just briefly for this afternoon, the important thing for us is that once the Southern Ocean started to fill that space and keep moving, cooling down, it deposited a lot of its sea floor along the southern edge of Australia. Let's have a quick look at that. Those blocks here represent tertiary limestone, the kind of limestone that Sergeant Jeff, who walked out, gave a talk this afternoon of the unconfined aquifers in the southeast, but that southeast limestone is only a tiny amount of the vast amount of tertiary limestone that's been laid at the door of South Australia in the Miocene. Here's the current coastline, which you can see out here, dotted lines, but this is where the full extent of all those tertiary limestones were laid 20 to 30 million years ago, perhaps a bit newer than that. So at one time, we had this vast amount of limestone, some of which is now on our continental shelf, but the South Australian mainland now has the remnants of that, has all of that there now exposed as the eastern Nullarbor, slabs of York Peninsula and the coastline here in Adelaide with our aquifers, and the upper and lower southeast and the Murray Basin. Now, that's an awful lot of limestone. So we say, yeah, limestone. We drive all over limestone, limestone. Why is it so important? Well, on a world scale, it's rare. This area here are the areas I just referred to, these big tertiary carbonate platforms that have been deposited on the southern edge of Australia. The equivalent area that has anything like it is the Caribbean in the eastern part, the Yucatan Peninsula, the Florida Peninsula, and scattered islands across the Bahamas. It's no coincidence, A, that there's very few areas like this around the world, and B, that they are located where they are. because these limestone platforms are located on the trailing edge of the Australian continent. That is, Australia's moving that way into the Pacific, bashing into the Pacific, pushing up New Guinea, and the back end here is not under any compressional forces at all, so there was nothing to destroy or damage the ocean floors, those limestone floors that were laid down. They are still intact. The same thing happens here as with the Atlantic Ocean, mid-Atlantic ridge is spreading either direction. This is the trailing edge of part of the American plate, so those limestone areas haven't been damaged either. But anywhere around the world where plates are bashing into one another, all that stuff got destroyed. Therefore, the limestone that we've got on our southern Australian coastline, although we've got a lot of it, is rare on a planetary scale, and the features in the limestone are rare on a planetary scale, which is one of my messages today. After a while, and I won't go into all the geological time scales, after quite a number of millions of years, you can see the South Australian coastline. Now these yellow areas, bright yellow areas developed. Now they are the Bridgewater limestones of the coastline and the cliffs, and Kangaroo Island, Eyre Peninsula and so on, and they're also down in Victoria. They are also limestone but much younger, and what happened effectively was, in simple terms, there was sea retreat, it came back in many times, eroded the limestone which was already preserved there, wore it away, dumped it up on the shoreline as dune systems, and those light yellow expanses are what we call reworked limestone, and all these Bridgewater Formation dune sequences in the southeast, Kangaroo Island, southern edge there, York Peninsula, you can see them everywhere. So they are the scrapings of the original limestone, but they also have their strong characteristics and spectacular appearances. If I just go back for a second, the next diagram is my only graph, and it's basically covering from here to here, and what it's saying is that we know that this back end of South Australia, the coastal area, has been uplifted at different rates over different times. This is just a small graph in the last, I think, 100,000 years or something, where basically it's saying in the western part of South Australia, uplift has not been so strong. In the Mount Lofty ranges it has, because the uplifted range, but in the southeast there's a hell of a lot of uplift occurring because of the volcanics and associated things underneath that southeastern and western Victorian province. So our South Australian coastline's being jacked up at different angles and raised at different angles at different geological times. This gives different effects on the limestones. Oops, here we go. So I'll start from the west and go to the east with half a dozen pretty pictures to wind up the day. This is the Nullarbor Cliffs, of course. You would know because you just drove across there or flew, whatever you did. A brilliant piece of coastline. A couple of quick things about this is to say that here we can see two main types of limestone. The Nullarbor limestone is the dark upper band. The white limestone is the Wilson Bluff limestone, which is equivalent to all those limestones in the southeast of South Australia, and the limestones down at Blanche Point and so on, down the Gulf here and so on. They are the tertiary limestones. We know that quite a lot of limestone's been eroded off the top, but here's what we've got today. The cliffs have been uplifted 100 metres because they're at this back end of the continent, and that's why we've got these things. And in terms of our national parks and marine parks, these are a really high profile item, but there's a reason why they are there. Inland there are thousands and thousands of blowholes. An organisation that I belong to, the Cave Exploration Group, runs records for the Nullarbor. We've so far numbered 12,000 blowholes, and we've hardly got over the border yet. There are also some very large and deep caves. I'll show you an image of one of them. This is DEWNR management responsibility, this cave. It's Canalda Cave. Some of you might have heard me give a talk on Canalda last year at this conference. There's the Nullarbor. There's the entrance to the cave, and I've spliced two images together. This is when you go down underneath into these gigantic chambers in this creamy coloured tertiary limestone that was laid down on the Miocene seafloor. You can see people for scale. You can see flint bands in the walls. And one reason why Canalda Cave is a management responsibility for DEWNR is that those flint layers were mined by Aboriginals about 26,000 years ago, And that evidence was started to be discovered in the late 50s and early 60s. There was a great deal of controversy about it because the teaching up to the time was Aboriginals had only been here for 5,000 years, and it was this cave and its evidence that disproved all of that. It was very controversial at the time. Now we know they've been here for twice that long. But that's a really important cave that DEWNR has management of. The South Australian Museum shares management. There's a bloody great metal gate in there to stop people getting in, because there's nothing to stop people driving across the Nullarbor to this place. So there's a management issue, an interpretation issue, and an understanding of the geology of the cave as well as the archaeology. Let's move along the coastline. This is Wedge Island, between Eyre Peninsula and Yorke Peninsula. Great big hunk of limestone, sitting up there, a little bit there. That's Baird Bay up the western coast of Eyre Peninsula. These limestones are the Bridgewater limestones. These are the ones where the sea has been out after it laid down the first limestone, came back, ground everything up, threw it up in great big heaps as limestone dune ranges. And if you look a bit more closely at them, of course they're wonderful habitats, these limestone areas, because of all their holes and crannies for crayfish and marine life and so on. But here's a better detailed photograph. This is taken where the Ethel wreck is on the bottom of Yorke Peninsula. But the point of my photograph is all these different cross-cut levels of constructions of different phases of Bridgewater limestone forming those coastlines. I'm not a specialist in those. I'm a specialist in the deeper limestone that we've talked about. But there is a different phases where dunes have been dumped up on here. They've calcified. There's been a climate change or a regression and transmission or whatever, and more dunes have cut across each other. A spectacular coastline. That's really good for DEWNR to be able to interpret for a lot of its marine and coastal parks. Coming closer to Adelaide, don't know how that bloke got in the photograph. Two aspects. This is the Northern Adelaide Plains up at Virginia. In our science team we spent a lot of time looking at groundwater use. This is one of our diagrams with wells and so on, profiles and so on. But the point about this one is that that big blue layer and this white layer in between, plus that skinny little bit in the middle, are the same tertiary limestones that the ocean dumped there in the first place that I've described, that they've now been bent and uplifted against the Adelaide Hills, and we draw all our water for it from Northern Adelaide Plains. When you go south to McLaren Vale and Blanche Point, there's another exposure to the limestone which the fault lines has shown, and there's even a bit up at Myponga, which I couldn't quite fit on the slide. Nearly done. When we come across to the Murray Plains, that river has a gorge. There's the cliff, and the reason it has that gorge across that limestone is that whole limestone's been lifting up like everything else, and the river's been cutting down through it. But that's quite simple for Geology 1 or Geography 1, but it's a really interesting message when we're talking about Coorong and wetlands and the Murray lands and so on to people who visit DEWNR parks all over the place. This is a shot taken from Kelly Hill Caves on Kangaroo Island. Two quick points about this. Abundant decoration because it is in the Bridgewater limestone, which water percolates through very, very readily. Great deal of decoration. If you look inside one of these dune type caves, this is what you see. Drastically bent layers of calcified dune. Looks like it's going to fall in on him, but it's actually quite stable. Delicate formation that we use for dating the ages of these events. Admirals Arch is a limestone cave of the Bridgewater Formation dumped on top of the basement rock along Kangaroo Island. It's a massive tourist attraction, but the story is ancient Gondwana rock with new, or relatively new, limestone dumped on the top from that infill from the Southern Ocean. Now just finishing off, coming to the southeast, this is a beautiful 3D model in the museum at Naracoorte showing all of these yellow lines running along here. It's been referred to a bit in earlier talks today. These are Bridgewater dunes, and they're not sand dunes, they're lime dunes. They are calcified, they're calcium-based, not silicon-based. Each one of them has been laid here by an ocean that's come in and out at different levels, and each time the oceans come in and out, the uplift of the land in the southeast has come up a bit further, So they are stranded beach lines, and it's one of the unique sequences of the world that shows this for the last 13 ice ages in the Pleistocene. This is the whole of the southeast. We've seen a number of talks, fascinating ones today. I've looked at the geology and said here are three main huge fault lines across this big sheet of limestone that have broken through the top, not through lower down in the aquifers, broken through the top. And the thing that we find is that wherever they are in this limestone sheet are caves. All the Naracoorte caves there, caves around Tantanoola along the Tartwalk fault line, and all the big sinkholes and cenotes are clustered along the Nelson fault line. And basically this tells us that limestone was lying there 15, 20 million years ago. It got broken by fault lines, groundwater got into the cracks, and that's why it's given us all of our caves and sinkholes in the array and the shape and the size that we find them. A couple of quick slides to finish up. Just some of the features in the southeast, since I started with the Nullarbor. Naracoorte's famous for its fossils. This is a dig in the sediment. You can see the sediment exposure here that goes back, I think, about 180,000 years in Blanche Cave, where Liz is working carefully on that. So the sediment within the limestone is fascinating, and it's part of the DEWNR story. This is a cave at Naracoorte where a big pile of sand has fallen through one of the natural solution pipes. These are fossil collection sites because animals fall through the same holes, and you can see reconstructions of some of the megafauna. That's also part of the DEWNR limestone story. This is a sinkhole, and the proper name is cenote. This is the Little Blue Lake down past Mount Gambier. This is not DEWNR responsibility, it's the Port Macdonald Council, but we have several others nearby. Now, they don't have interpretation signs, and yet these things are really rare. We've got several dozen of them in the southeast, and the rest are in Mexico, and that's it. Lastly, a couple of slides. We saw Ewan's Ponds and how beautiful it was, and the message that Margaret gave. These are the three ponds in a line that run down to the sea. You can just see some views of the aquatic growth and the pleasure for divers in diving inside these ponds. And yes, there we go. Reclaiming the coastal karst springs of the southeast and Piccaninny Ponds, which is a canyon. My last slide just shows where have we been. We've been right along the coast of South Australia looking at the limestone. A lot of this stuff offshore is still part of that, but it's now the continental shelf. I've showed you dry land karst, cliffs, caves, sinkholes and karst springs. Now DEWNR manages parks all the way along here, and part of my message is that we could look more cohesively at a karst policy or ways of promoting it or ways of studying it. Some states have even got karst officers who specialise in the science of karst in states where there's hardly any compared to what we've got. That might be something to think about. And my last image here, with all the coloured dots, is an array of the various heritage sites we've got in the state and geological monuments various societies and our department have identified as really important. So you can see how many of them are around the state. Along the coast, there's just so many of these features, many of which are the limestone ones I talked about. And I'll leave you with this last thought. There's a big conference in the middle of June, the Australian Earth Science Congress, and we're also looking, although this is not limestone, we're looking at geological features along a giant trail like the Hyson Trail all the way up the spine of South Australia, which is the one area which sticks up higher as compared to the coast. So I just wanted to draw your attention to all that DEWNR has under its management, with perhaps a bit of an appeal to think about our karst resources in a much broader sense, because we've got a lot of it, but the world doesn't. So thank you.